Welcome to all. In the next second part of the detention pond design using the hydraulic toolbox software. Okay, so in the last part of the video, so we have learned about the detention pond concept. Okay, and the types of the outlet structure which are proposing in this example. Okay, and we have gone through the case study where I have shown you this inflow hydrograph. Okay, the pre and post developmental flow or run flow and runoff volume. Okay, so based on this runoff volume, so we have initially or you can say tentatively calculated the sizing of the detention pond. Okay, I mean to say we have just fixed the dimensions of the detention pond. It's not the outlet, it's only the storage area. Okay, so here in this part we will incorporate those data into our model and design these outlet structures for this detention pond. Okay, so here you can see I have already opened this hydraulic toolbox software. So in the last video I have given you the download link for this hydraulic toolbox software. It's an open source software developed by FHWA, that is Federal Highway Administration. Okay, so here, initially I have created a new project. Okay, so in the new project I am going to define this retention pond. So here for that I need to right click, and here the new detention basin analysis. Okay, so I have defined this new detention basin analysis. So here in that, right click on it, and I need to add this basin data. So basin data is nothing but what we have calculated the pre and post developmental runoff volume based on this, that we have initially fixed the tentative sizes of the detention pond. Okay, so let me go to that spreadsheet. Okay, um, so this is the spreadsheet what I have shown in the last video. So these data, and this is the inflow hydrograph, that is nothing but the post developmental inflow hydrograph, which is going to add as a input to the model. Okay, and so this is the runoff volume, design runoff volume, and based on which our storage structures are proposed. Okay, so this is the sizing. It's a tentative sizing of the detention pond. It would be trapezoidal pond. Okay, which is having the trapezoidal sections, and there are two types of outlet structures we are going to propose here. One is the standpipe and another one is the pond riser. Okay, so let's move into the model. So here in the detention basin analysis, so initially we have to define the storage. So storage is nothing but the sizing of the reservoir or the pond, detention pond. Okay, so I have this noun geometry which I calculated in the last video: 65, 42 and 3.5. 65 is the length. Okay, 42 is the width. Okay, and 3.5 meter is the depth. Okay, and side slope of the channel I am considering the 2:1. Okay, so that's I'm mentioning it's 2:1, the side slope. Okay, and here it's a base elevation. So base elevation is the nothing but the reference elevation based on which we'll fix the elevation, or nothing but the invert of each of the outlet structures, that is a pond and the standpipe. Even if we have the where we have to to fix, we have to mention these levels with respect to base elevation. So as of now I will consider the base elevation as 10 meters. Okay, so here this is the base elevation. Let me show you the picture. So this is actually the base elevation, the reference elevation which you are considering to find the reservoir storage and the invert of the outlet structures. Okay, regarding the number of data points of the storage, I'll define 100. Okay, so initially I have defined the storage details. Now I need to define the outlet outflow discharge, so nothing but the flow going out of the pond from this outlet structure. For that I need to define this outlet structure. So here are my outlet structures. Okay, so I can in this hydraulic toolbox, so I can define unknown discharge, adding weir, adding stand pipe, add the pond riser. So in this example, I am going to add the two of the outlet structure as I mentioned earlier. That is, one is the riser and another one is the pond. Okay, so this picture gives better understanding. So what I am going to do. So okay, so this is actually the stand pipe. This one on the purple color. Okay, and this will be the pond riser. Okay, and this is a weir. Uh, Where but which we are not going to model in this video. Okay, and this is actually the drain pipe. So whatever the outflow discharge coming from out of this stand pipe plus pond riser will be drained out through this culvert or a pipe which is called as a drain pipe. As of But the limitation of this hydraulic toolbox is that we can't design this drain pipe. We have to use some other software, but for the stand pipe and the pond riser, so we can use the hydraulic toolbox to design these outlets. Okay, so let me consider this pond elevation, pond riser and stand pipe. Okay, so these are the two things which I am designing. Okay, so initially I will mention the sizes of the tentatively fix the sizes, and I will check the routed hydrograph, and once again I'll check the storage, and once again it will be like trial and error to design this stand pipe and the pond riser designs. Okay, so let me go into this hydraulic toolbox once again. Okay, so I will define this add riser. Okay, so add riser, my section would be circular. Okay, and pond diameter in the initially I will consider uh, 0.15, or its diameter is 0.15 meters. Okay, and base elevation is 100. The base elevation is 100 is nothing but this invert of this retention pond. Okay, it is asking the where the invert of this this pond riser starts. So this invert is nothing but this invert from where at what elevation it starts, this elevation invert, because this bed of the retention pond is at plus 10 meter. Okay, so it would be at least 0.2 meter above the invert of this detention pond. So okay, so I'll mention it as 0.2 meter. Okay, so bottom of the opening is nothing but the invert of this pond riser is 0.2 meters. Okay, size I have initially defined as 0.15. This orifice coefficient I considered as by default 0.6 meter. It will vary based on the if any types of grades are there. Okay, grating structures are there. Okay, okay, so this is my initial set. Okay, next I'm going for the stand pipes. Okay, so stand pipe is my second outlet structures. So second outlet structures. Okay, so here is a stand pipe structure. Okay, so here from when it act as a emergency escape structure when the water exceeds this stand pipe area. So when the water level exceeds, So when the water level exceeds, it acts as an emergency escape for the storm runoff. So this is act as a emergency escape for the storm runoff, and flow is similar. Flow hydraulics are similar as a shaft spillway. Okay. So let me consider this level. So since it's a 10, this invert is at bed of the detention pond is 10, and from there it is zero point 0.5 meters. Okay, and here it is at 3.5 meters, nothing but the crest of the pond, so crest of the weir. Okay, the diameter I considered a bigger diameter for the standpipe. Okay, so it will be like 1 meter, and base the height above the base elevation, it's around 3.5 meter. Okay, so this is my initial run, but it will change based on our requirement. Okay, so this is my storage structures. Okay, now I need to define the inflow hydrograph. Okay, so inflow hydrograph, uh, how many columns, sorry, how many rows we need to connect, create 69 rows. Okay, 69 rows. Okay, 69 points, x y z, x and y points, we need 69 numbers. Okay, so we have this table is it is developed from HMS model. Okay, so I'll copy this and paste it there. So this is a hydrograph. So this is an inflow hydrograph. Okay, so let me copy paste this one. So this is that inflow hydrograph which we are using. Okay, so and the initial condition, you can see that this detention basin has overflowing. It's mainly due to the undersized riser. Okay, but still we can check the this pond hydrograph. Okay, so this is actually the inflow. Let me zoom it. Yeah, so you can see this blue color line is the inflow hydrograph, and the red one is the routed hydrograph, is nothing but the outflow from this riser, net outflow, this total outflow from riser and the standpipe. Okay, so it shows that we have to make a larger pipe openings here. Okay, so which we have to go in the next run. Okay, let me go with higher sizes of the pipe. Okay, uh so standpipe I'll keep as it is for riser, but I have to increase it the size by zero point 0.5 meters in diameter. Okay, and I make this standpipe little bigger, make it 1.5. Okay, let me check it. Okay, so this is actually the the outflow discharge now, but in this case it is not overflowing. Okay, so this is the storage. Okay, but in this case it is not overflowing. But what I can uh, do to design as per our guidelines and what I told earlier in the last video, I need to design this retention pond such a way that the peak discharge from the pond outlet should be 3 Qmax. That is nothing but the pre-developmental peak discharge. So that is we are going to discharge into the municipal system, and it is allowed as per the guidelines. Okay, so we will design this outlet structure such a way that it can deliver slightly below 3 Qmax of the peak discharge. So that is how we will design that. Okay, let me go with the higher dimensions for the outlet structures. Okay, uh, or what else I can do here. So instead, uh, if I propose another riser, pond riser, so something like this. So this is my first pond riser. I'll propose another pond riser here. So this will be my second pond riser. Okay, this is my second pond riser that I am going to propose here. Okay, uh, pond riser. It will be having circular sections. Another same as earlier. It's a point. It will be like same as earlier. 0.5, and it is placed 1 meter above the base elevation, or make it 1.2 from the base elevation. Okay, so let me see. Still I need to make some modifications here. So as I mentioned earlier, I need to design this outlet structure such a way that it can discharge the peak outflow flow of 3 meter cube per second. So I need to keep it slightly below this pond outlet discharge. So I need to go for higher sizes here. Uh, Let me consider the higher sizes for pond. I make it point 0.6 and point. Let me point 0.6. Sorry, point 0.6 and point 0.8. Okay, we are very near to the our desired. So what we desire is the outflow discharge slightly lesser than the 3. Okay, let me go with higher standards here. Point 0.8 and here point 0.9. Okay, still we need to make some changes here. Let me what else what I can do here? So here, so instead of two riser pipe, I will make a single riser pipe with a larger diameter. So I will remove this riser 3. Okay, delete this one. I'll keep riser 1 with the larger size. Let me make it 1.4. Let me make it 1.4 meter in dia. Okay, and let me see. So here I'm getting a huge flow discharge at the outlet, but I need to shift my peak outflow discharge at the outlet should be less than 3, slightly lesser than the 3 q max. Okay, so I need to make some further changes in the riser 1, spawn riser. I'll make it 1.25 here. Let me check. Still I need to make slightly a less small change. Still it is over 3. It could make font riser at 1.15. I'll keep a standard size 1.2. Okay, we'll make a small change here. I'll keep it 1.10. 1.10 meters. So this will give a desired result. Yes. So this is absolutely a fine result. So you can see this peak discharge at the outlet is slightly lesser than the pre-developmental rate discharge, that is 3 q max. It is here, it is around 2.7. Okay, if you want to get these details, so here is the storage curve for this one. Okay, it's not a linear, it's a non-linear one. Okay, and this is storage area hydrograph. Okay, and so you get this in the form of a table. Okay, so here in the form of table, same for this one in the form of graph. Okay, so this is our final sizing here. So first one riser, so which is sorry, first one is the riser, which is having the opening diameter of 1.1 meters and placed at 0.2 meter above the base of the base elevation. Okay, and the second one is the standpipe. Standpipe is at 3 meter above the base elevation, so base elevation is 10. Okay, and its pipe diameter is 3 meter. Okay, so thank you for watching.